Hi everyone, my name is Summer, and let's get started with today's LeetCode question 907. It is marked as medium, but it is little bit trickier also. So we'll start with the brute force, then we will go to optimize our code. Okay, so without any further ado, let's get started with. Let me share my screen first, guys. Okay. So question is 907 sum of subarray minimum. Okay. So here, like we have given an array, and we have to first find the subarrays of all the given array. After that, we have to find the minimum of each subarray. Then we have to sum it. Okay. For example, here our given element is 3, 1, 2, 4. Okay. So here 3 is one subarray, 1 is one subarray, 2, 4, they are all subarrays. Okay. And 3 and 1 is also subarrays. Subarrays are those who are in continuous. Okay. And 3, 1, 3, 1, 2, 1, 2, 3, 1, 2, 4. Similarly, other elements. Now from each subarray, we have to find minimum. So here in this given subarray, 3 is the minimum. So 3 will be the, so I will add 3 in my sum variable. Similarly, 1 is the minimum in this variable. If we check this element, 3, 1, 2, 1 is the minimum. So I will add 1. So similarly, I will find all the minimum, and at the end, I'm getting my answer 17. Okay. So now, like I will start with the brute force approach first. Okay. I will start with the brute force first. Okay. So here in the brute force, what I will do is I will first find the each sub arrays, and then also inside that to follow, I will find the minimum element from the given subarray, then I will add it in a new variable sum. Okay. And at the end, I will just simply return. So here is the pseudocode kind of thing. Here, for example, for I is equal to 0 till n is the number of element. Also, there is again one more for loop, j is equal to I. I will start, like here, this is the element 3, 1, 2, 4. I will start I and j from this. Okay. It will also traverse till n. Okay. Then here I will take one variable val, which will store my uh, first value, which is array of I. Here in that inside the second loop, I will find the minimum. Okay. So what I will do is I will call one variable int. I will update my value. So value is equal to minimum of val or array of j. Okay. After that, I will add it my given variable. Sum is equal to sum plus val, and then I will take the modulus m. M store 10 to the power 7. Okay, because 10 to the power 9 plus 7, because there might be a huge number, so we have to modulus it. And after that, I just simply return my answer. Okay, so here you can see that I am using two for loops. So here it would be order of n square. Again, inside this, I am also finding the minimum. Okay, so our worst case would be like order of n cube time complexity. But here, if we see the constants, it is like 3 into 10 to the power 4. So it will give me, this approach will give me time limit exceed. Okay, so first I will code the brute force approach, then I will explain the optimized wala code. Okay, yeah. So let's start with the brute force wala approach. First, I will initialize my modulus function m is equal to 1 e9 plus 7. Then I will find the total number of elements. Then I will do the to for loop to find the total number, to find the subarrays. Here I will store my minimum value, array of I, and here I will I will store my minimum value from the given subarray. Min is equal to value or array of j. Also, I will call one sum function and sum equals to 0. Here I will add inside my sum modulus. Yeah, at the end I will return sum. So our code got accepted, but when I submit it, it will give me just wait. So after submission, it will give me TLE. So out of 87 test cases, 79 got passed. So now let me explain the optimize wala code. So to understand it better, let me take one another test case. Okay. So our test case would be 0, 3, 4, 5, 2, 3, 4, 1, 4. Suppose this is our given array and we have to find the sum of subarray minimum. Okay. So what intuition we can apply it here? Like what approach are coming, which like what logics came in my mind. So after observing it, like what I am thinking ki, like I will choose a given element. Suppose I'm choosing 2 and I will find the given range where 2 will be my minimum in that sub array. Okay. For example, I am in the range of 3, 4, 5, 3, 4. Okay. Here, if I find the sub arrays for this given array, okay, this given array, so in each time I will get 2 as a minimum value for that sub array. Okay. So, so what I will do is like I will find the range till which I can go. Okay, for example, here in this array, if we see like how many sub arrays were there, where 2 will be my minimum. Okay, suppose I will traverse with like I will start with 3, 4, 5, 2, 3, 4. Here 2 is the minimum, and then I will start like 4, 5, 2, 3, 4. Here 2 is also minimum. Then 5, 2, 3, 4. Here 2 is also minimum. I can also do 4, 5, 2. This is also sub array, 2 is minimum. 5, 2. This is also sub array, 2 is minimum. 2, 3, 4. 2 is minimum here. 5, 2, uh, 4, 5, 2. This is 3, 4, 5, 2. Okay. This here, 2 is also minimum. So here, if we can see, like there are more sub arrays where 2 is minimum. So if we count like how many sub arrays were there, so what I will do is like I will find my given index. I will find my index where I will find the two indexes on the left side or the right side where my given element is less than that element. For example, here 0 is less than 2. This is the first value which is less than 2. And here in the right hand side, 1 is the minimum value which is less than 2. Next minimum value which is less than 2. And here the index is 0. And here the index is 7. Okay. Now what I will do is, and here 2's index is 4. Now what I will do is I will subtract my fourth index with zeroth index. I will get 4. And here I will subtract 7 minus 4 index is equal to 3. So here 4 into 3 equals to 12. So there are total 12 sub arrays where 2 is my uh, minimum element in that given sub arrays under this array. Okay. And after that, what I will do is 12 into multiply with that element 2. So my answer would be sum would be 24. If I take this range where 2 is the element, okay, like I'm finding for each element, I'm finding the next smallest element and previous smallest element. Okay, then I am calculating that how many subarrays were there where that given element is the minimum, and then I will multiply with that given element to find the sum. Okay, so I will do this approach with every elements. Okay, for here, like for if I take 3, okay, so here 0 is the minimum element. Okay, this is the previous minimum element, and in the right hand side, 2 is the previous minimum element. And if I see the index like 0, 1, 2, 3, 4, if I see the indexes, so 3's index is 1. So if I find the left side like 1 minus 0 is equal to 1, and in the right hand side 4 minus 1 is equal to 3. So 3 into 1 is equal to 3. So there are 3 sub arrays where 3 will be our minimum element. So let's find that 3 sub arrays. So here 0, 3 is one sub array. 0, 3, 4 is also one sub array. 0, 3, 4, 5 is also one sub array. And 3, 4, 5 is also one subarray. So take total 1 into 4 minus 1. 0, 1, 2, 3, 4. 4 minus 1, 3. 3 into 1. Okay, wait. There are 3 subarrays. So like here I'm because this is wrong. Okay, because 0 is minimum. Okay. So there are 3 subarrays. So first subarray is 3, 4. This is one subarray. 3, 4, 5. This is one subarray. And 3 is the only one. This is one subarray. So there are total 3 subarrays where 3 is the minimum. So in this way, I'm finding every element's total subarray. Then I will multiply with that given element and then sum it up. Okay. So this is the complete logic. So here, what we are doing is we are finding the next smallest element, next smallest left element, and next smallest right element. Okay. Yeah. Now let's try this with our given test case, which is 3, 1, 2, 4. Okay, this is our element. Yep. So here, let me start with the next smallest element array. This is the left side. We are finding this side wala, and here is NSR. This is the right side, next smallest element. So here, for suppose here, 3's smallest element is there is nothing. So what I will do is I will put -1. For 1 there is no left smallest element. I will put -1. For 2 there is one smallest element. So I will update it as. So I will, what I am doing is I am updating the NSL with the given index whose next smallest element is whose element is less than that given element. So here I will put the index for first element, which is 1, and for the 4, 2 is the left smallest element, next left smallest element. So I will put 2 index here. Similarly, for the next smallest right element, for 4, there is nothing. So what I will do is I will update it as 3. Like I'm updating as n. Okay. Not 3. And because we are out of loop, so I will update it as 4. Okay. Now for the 2, there is no smaller element, so I will update it as 4. For 1, there is also no smaller element on the right side, so I will also update it as 4. For 3, there is 1 is the smallest element, so I will update it as 1. Okay. So I will create NSL and NSR. Then it is easier for me to find the total number of subarrays for that given element. Okay. Yep. So after that, what I will do is for NSL and NSR, the best way to find this is using stack. Okay. So I will use stack data structure to find my next smallest element and next smallest right element. Okay. So after finding it, so let me try run it here. Like suppose we are taking the stack. Okay. Here my element are 3, 1, 2, 4. So I am trying with next smallest left element. So initially I am at 3. And if my stack is empty, so I will put -1 in my first element. Okay. And I will update my given element's index. Okay. So I will update it as 0. So I'm inserting only indices. Okay. Now I am at 1. Okay. Here, I will check whether the previous element is smaller or not, but it is not. So what I will do is it is greater. So what I will do is I will pop out. So it is removed. Okay. And then I will check if my stack is empty or not. If it is empty, I will insert -1 and updated my stack as 1 index. I'm pushing it, the 1 index. Then I am at 2. So I will check whether there is any top element whose value is smaller than me or not. So there is one element which is smaller. So what I will do is I will push my top element. So here it is 1. Okay. After that, I'm at last element 4. Then here, and after pushing it, after updating it, then I will push my element index. So 2 will be added here. Now I'm at last index 4. Then I will check whether there is any element stack top is there which is smaller than the given element 4. So 2 is smaller, because 2 is the index. So array of 2 is equal to 2, it is smaller than 4. So I will update my NSL with my index for that element which is smaller. So I'm updating their index 0, 1, 2, 3. So I'm updating this one. And after that, I will just simply push it. So this is the NSL. Similarly, I will do it for NSR also. Okay. So in this way, I am following the NSL and NSR. I'm creating NSL and NSR for the given. Okay. So this is the stack. Now let's try run it. Now let's try the pseudocode like in the simple form. Okay. So what I will do is first I will find the total number of values. Okay. Then I will create a 2 vector. Then I will create a vector NSL where I'm calling function NSL. I'm passing my array and my given element. So it will return the NSL vector, this one here. Similarly, I will call for NSR here, function NSR, which will return my NSR using this operation. So I will write one function operation using the stack wala here. Okay. After that, I will do the for loop. Okay, I is equal to 0. till I is equal to n. Okay. Inside the for loop, I will find my first. I will find the range, like till which range I can take that given element as my minimum. So I will declare one variable d1 where I will store my left side range. So here I will what I will do is I will do I minus nsl I. It will give me the left side wala element, and d2 variable it will give me nsr I minus I. It will give me the right element. Then what I will do is I will take one variable sum where I will multiply d1 and d2. It will give me the total sub arrays, sub arrays for that particular element. After that, I will uh, I will multiply with I will multiply it with the given element. So result equals to array of I into sum. Okay. So here this sum is for that given element only. Okay. Now I will apply this with all other elements also. Okay. So here result would be this one, array of I plus sum. Yep. So here my final result would be uh final result plus result sum, this one, modulus m, and return my final result. Okay. So this result sum is for the given element sum. Then I have to find for. Okay, that's why I'm writing this one. And at the end, I'm just returning function fr. So here, this will take order of n time complexity. And for the function wala, which I will do using the stack, for that I will also do it using the order of n time complexity. Okay. So without any further ado, let me start with the coding part. Okay. So let me share my screen first. Yep. Also, I will start, like I have to also update because answer is too long. So I will use a long variable. Okay. Now I will find the total elements and n is equal to array dot size. Then I will store my NSL and NSR using one function. NSR equals to solve NSR. I'm passing array and n. Vector int NSR equals to solve NSR array of n. Now I will declare one variable sum. LL sum equals to 0. Then I will use my for loop. A plus plus. Then I will declare two variable d1 equals to I minus NSR NSL I minus I. Yep. So here I'm only dealing with indices to find the total number of subarrays with that given element. NSR I minus I. Okay. After that, I will do total sum LL. Total sum equals to D1 into D2. Then LL sum total equals to total sum into array of I. Okay. After that, sum equals to sum plus sum total modulus m. Yep. At final, I just simply return sum. थोड़ा वेट कर. Hmm. Now I will write my solve NSR and solve NSR. So here I have to return vector of I have written vector. So here my return type would be vector int solve NSR vector int ampersand AR int. Here I will take one result variable result vector to return my result. Also for NSL, next smallest element, I am using stack. Stack and listing. Got it. Now I have traversing for n I is equal to 0, I is less than n I plus plus. If st dot empty, then simply result of I equals to -1. Else, I will check first why. If my stack is not empty and an array of I and st dot top is greater than st array of I. If it is greater, then I simply pop out that top element. Okay. Otherwise, my result would be if it is empty, then it will return -1. Otherwise, it will return st dot top. Okay. And at final, I will push it. Result st dot push I. Yep. And finally, I will return my result. So this is the NSL, next smallest element. Similarly, I will copy paste this whole code to find the NSR, next smallest right element. I will just change it. And here, I'm updating my result from the right side. I'm traversing from the right hand side of array. So here I equals to n -1, I greater than equals to 0, I minus minus. If result I is empty, so I will update it as n. Else while empty and stop array will stop as empty, updated my value. And okay. And here I just simply return result. Yep. So let me check it again whether this code is correct or not. So yeah, let me run it. Okay, at line number 16 I got an 34. 48 expected error. Okay. If LLD1 error expected it now. Okay, it would be silly mistake. Okay, there's some error. Runtime reference binding to null pointer int. Okay, now I know where I'm getting some error. So first I will update it at the top here. Secondly, like here, I'm just checking the index because stack is storing the indices, but here I have to find the values. So here array of this one. Yep. So I hope this is correct. So let me run it. Also, one more thing I'm missing here. Here I have to initialize my result as initial number of element is n. Also here that's n. Now it got accepted and let me submit it. If I submit that, why did I'm getting the wrong answer? Okay, here equals. So after submission, I'm getting the correct answer. So like initially, if you can check if I remove this greater than equals to wala, if I greater than equals to wala, then it will give me the wrong answer. But here, if you can see, I'm not using greater than equals to, I'm using greater than only. So let me also explain the small part ki why I'm using greater than here and why I'm using greater than and equals to here. Either you can take why I'm using greater than here. Okay. Suppose if I take one variable 2, 1, 3, 4, 2, 1. Okay. So here, in my given, in my here, like here, it is 1. Cut it. 1, 2, 3, 4, 2, 1. Suppose this is my element. Okay. Here twos, if I am at tooth value. So here in the left side, smallest is this one. In the right side, smallest is this one. So I have to find the total number of subarrays having 2 is in the minimum. Okay. So here, if I see how many subarrays were there, so 2 minus 1, 1 into 0, 1, 2, 3, 4, 5, 5 minus 1, 4. Total 4 subarrays. Okay. For this two also, if I check how many subarrays were there are total 4 subarrays also. But here two are, but here in the given subarray, this two is repetitive. Okay. So we are traversing a few subarrays where we are repeating 2 as the minimum subarrays. Okay. So we are repeating subarrays twice or thrice in some values. Okay. So we have to remove that subarray. For example, if I see like 4 subarrays where 2 is the minimum, this 2 is minimum. So 2, 3, 2, 2, 3, 2, 3, 4, and 2, 3, 4, 2. These are the 4 subarrays. Now, if I see this 2 as a subarray, okay, as a minimum in that given subarray, so 2, 2, 3, 2, 4, 2, 3, 4, 2, 2, 3, 4, 2. So there 2, 3, 4, 2, 2, 3, 4, 2 are repetitive and 2 are repetitive. So we are traversing 2 extra subarrays which are repetitive. So to avoid that, we are in one case we are using greater than equals to, and in other case we are only use greater than. Okay. So in this way we are avoiding the repetitive wala subarrays. Okay. So this is a small problem which I'm facing earlier. That's why I'm getting some error. So now this is applicable if we have repetitive elements in the given subarray. Okay. So I hope you like this video, and it is more informative because there are some approaches like we are using stack, and we have find the NSL, like how to find the next smallest element, next smallest left element, next smallest right element in this approach. So it is a good problem, by the way. So I hope you like this video, and we'll see you in the next video, guys. Bye.